In this year's Sound Capstone, students worked in teams to design and develop a variety of sound applications, from analysis of music and human hearing to constructing musical interfaces using sensors for movement and gestures. All of the projects utilized multiple engineering solutions to problems of analysis, sensing, and playback, and integrated both hardware and software.
We're working on the Physio Acoustic simulator, which lets normal people listen to some audio and then simulate how people with hearing disabilities would hear that audio so they can compare the difference. So it helps to understand people with hearing loss and then what cochlear implants do.
Well, I'm hard of hearing myself. I have profound hearing loss, and people are always asking me whether I can hear something or whether I can't hear something. Like, they'll play a sound clip and be like, what does this sound like, or something. And I thought it would be a good idea to actually show other people how that works.
What we have up here is a bunch of filter controls, so the user can select to filter out all of the sound or filter out none of the sound, or some combination of the two. So I'm going to set it up for a sample hearing loss of someone with old age. So up here they can hear the lower frequencies pretty well still. As the frequencies get higher, they become harder and harder of hearing. So we have a sound file loaded up here which is jingle bells. So I'm going to run the filter on that. And down here we have the spectrograms of jingle bells. So this is the unfiltered sound with lots of high frequency noise up in this range. And this is the filtered sound where most of the high frequency sound has been removed. And here are the differences between the two.
So our group is the virtual drum kit. Our goal is to make a working drum kit that you can use in an apartment or someplace where you can't actually have a real drum kit because they're too loud. And we wanted to use off-the-shelf hardware so that you basically with just some source code anyone could make this project. So the basic inputs to our device are two Wiimotes. They have a couple of advantages. One, they have built-in accelerometers so they can detect hits in real time, like an actual drum hit. And two, they actually give feedback, haptic feedback in the form of vibration right in the Wiimote itself, so you can actually feel when you hit the drums. And then we use Connect to do 3D positioning so you can tell which drum you hit. And the buttons on the Connect allow you to add drums, change drums, really completely configure the drum kit however you want as you're playing. And using the Wiimotes, you can actually change the view on the screen itself, so you can zoom in and out. And by pressing a button, you can add a drum, and then you can change the sound.
We actually have three target audiences. Number one is just general musicians who want to use our program to record music. Another one is real-life drummers. A lot of times they don't have the room or the space, or they have neighbors who will complain about the noise. So this gives them another way to practice. And our third is just the general public audience for use in gaming, something to just sit back and enjoy.
Our project is a music transcription game. Basically what we're going to have is a GUI where users can input a bunch of notes, and then you can have the program play the notes back to you. And so it does that through software that we've built.
For writing down a song, a lot of people, especially without musical training, that's a pretty hard task to do. And it's also a task that's difficult for computers to do.
I think it was on the first day that we were talking about the project, we decided we could have a human element also exist with the computer element to make the transcription easier. Because it's hard for humans by themselves to transcribe music, it's hard for computers. The mixture of the two, where the computer does some initial transcription and then the human corrects it, can be like a good mix of the two.
Well, basically what we've got here is an editing interface. We wanted it to be easy for people to use whether they had musical training or not. So it's set up a bit like a piano roll. So basically the vertical axis represents the pitch, and then the horizontal axis is the duration there. So.
This is our magic glove. The idea is it has 5 pressure sensors, one on each fingertip. Those loop through to an Arduino, which handles the signals and sends them via USB to the computer, which then it turns it into music. And the idea is you can have a sample attached to each of your fingertips. So when you press the button, it plays a sample. Now that by itself is okay, but you only have 5 buttons, and so you might as well just have a keyboard. What we decided to do to make that a little bit more exciting was to incorporate computer vision and color tracking so that you can place the glove beneath the camera and it tracks the position, the XY coordinates of the glove. And as a result, each grid square that's lit up when I move the glove around corresponds to 5 different samples, 1 for each fingertip. That gives us a lot more samples that we can play with, and then we can make music out of it. So that's looping, and then when I want to, I can lay down another one. So that's the idea. So this is this set of samples is all for like a dubstep kind of genre. So it's pretty distinct, but that's the idea.
So our first idea was to make the atrium into a sequencer. So the idea being everyone in the atrium is a different noise, and we can use the camera over the atrium to figure out who's where and what time that would correspond to in music, but it just got too complicated and it was way out of our scope, so we had to really drill it down. And then we came to this idea of like music interacting with itself, and then eventually we got to this idea of having a physical interface to make music with. It's always kind of the dream that you could make music more naturally than having to learn these instruments and stuff, so we thought, you know, finger tapping is kind of like an instrument, so we kind of went with that, and out came our magical glove of fury and music. And
so this project, we discovered that all 3 of us really enjoy art, and we enjoy kind of the artistic creation of music. And so with our project, we look to how can we build an instrument that we all could appreciate and use. We started out with the idea of using a camera to track objects, because we were interested in maybe light painting, where you have like a light in a dark room and you can do all these cool photography things. We wanted to bring that same idea to music. We also had a separate project that was developing this glove, because we had these touch sensors, and we found a good way to merge the two by creating this sampler. I think we are targeting the experimental musician, the person who's out there that wants to try something new, that is interested in pushing musical instruments into the digital age.